Right, so we looked at the Peterson solution. We saw that it works only for two processes. We realized that we need something better. So here is another solution to the critical section problem, which is called Mutex lock. So Mutex is a short form of mutual exclusion, which is the first and foremost criterion which we are trying to satisfy in the critical section problem, right? So the name of the solution, I said, is Mutex lock. So it is basically achieving the principle of mutual exclusion using something called a lock. So what happened in your Peterson is you had this thing called turn and you had this thing called flag, two separate data entities which were shared between the processes. Now we are getting rid of all that and we have one entity which is called a lock. So lock, you can think of it as a Boolean variable. So we generally speak of a lock in terms of available or not available, which you can equate to true and false respectively. So think of lock as a Boolean variable. So every process which works with a particular data. So if you have like some n processes which are working with the same data entity, then for all of them there is one common lock. So if you go back to your Peterson, there was one turn variable which was shared between both the processes, and this flag variable, every individual process had a separate flag of 1, flag of 2 and so on. Here there is one lock and it exists it is common for all the processes which are working on the same data. So you can think of it like the locks we have in our homes, right? Your main gate or whatever has a lock. So that lock is common for everyone residing in your house, whether you want to enter your house or your parents or a friend or whoever, they need to open that lock and enter, assuming the door is locked, of course. So it's not like every person has their own lock. Every person has their own key, but the lock is the same. So the lock is not for a person or an individual, but for the house, for the building. Similarly, the lock here is for the data which you are dealing with, the data you are modifying, and not for the individual processes. So every process which wants to modify the data should first acquire the lock, then work on the critical section where the data modification happens. Then you release the lock so that someone else who needs the lock can take it up, and you continue with your remainder section. So this is the basic idea of Mutex lock. So whenever there is a process which is being executed, you will first acquire the lock, work on your critical section, release your lock, work on your remainder section. So while you are working on the critical section, the lock is yours, meaning nobody else has access to the lock, so nobody else can work on their critical section, which means mutual exclusion, right? At any given point, at most one process has the lock, so at most one process can work on the critical section. First point. Second point, as soon as your work is done, you are releasing the lock. So any other process who wants the lock can acquire it immediately and start working. So bounded waiting is also satisfied. That condition also checks. Third and final condition, progress. So if nobody has the lock currently, then you go and ask for the lock, you will be given it immediately and you can start working. So progress requirement is also satisfied. So the Mutex is a very simple logic which says there is a lock on this data item, a lock associated with this data item. If you want to make a modification, acquire the lock, then go modify it, then release the lock, and then come out and work on your remainder section. And we just saw how it satisfies all three conditions: mutual exclusion, progress, and bounded wait. So how exactly do these acquire and release work? So the acquire function is defined as follows: while not available, meaning when the lock has already been taken up by someone else, you will simply wait. And that waiting is called busy waiting. So we'll look at busy waiting in detail in a minute. So as of now, understand, when a process wants to access its critical section, it will call the acquire function. What does the acquire function check? It checks whether the lock is available. If it is not available, you will do something called the busy wait, which is you are simply waiting for the lock to be released. Once the lock is released, you are taking it up. So again, you are setting it to false, meaning the lock was just released. You take it up now, so again the lock is not available. So you are setting it to not available. And in the release function, you are giving up control, so you are simply setting available to true. So coming back here, what is happening? when a process wants the lock, it will initially, when no one has taken the lock is available, right? So P1 comes, it wants the lock, it sees the lock is available, so it will take the lock, it acquires the lock, so it sets available equals false. It is working on the critical section. Now let us say P2 comes, it wants the lock, it checks, lock is with P1, as in lock is not available, so P2 will wait. Meanwhile P1 is done, so it releases the lock, it sets available equals true, and then P1 goes to do its remainder section. Now P2 checks, the lock is available, so it will acquire and then it will start working. And same thing. So that is how acquire and release are defined, and that is your mutex lock.